Hey everyone. Today I need to do a bit of a production run. So on this intake that'll be shipping by the end of this month or so, you can see right here when you use the stock fuel injectors, the fuel rail needs to be spaced up, and right now it's using 3D printed pieces. I don't want to ship 3D printed pieces, I don't. So we're actually going to make them out of Delrin, which is a much more appropriate material for the engine bay. And this is the first time that I'm going to make any kind of a production run. There's actually several pieces on this thing that are going to be produced in here, but this one in particular, even though it's a super simple part, for each one of these that I sell, I need 6 of them to go with it. So just for the first 10 pieces, I need to make 60 of these. So we're going to work on making them and making them quick. Otherwise, I would just use the manual mill, make a couple of these and be done with it. Step 1, we're going to need a way to hold these things. We're going to use some soft jaws. I've got some blanks right here, but let me walk you guys through the process that I do for this. So first we're going to open up SolidWorks, and this is a pretty simple job. I'm going to start by just drawing up the soft jaws in there, mirroring it, make a second one, put my 5/8 inch hole for the dowel in there, and then a little bit of clearance on the bottom so that the drill doesn't hit the soft jaws, and also a little clearance at the top so that I can chamfer these things. And that's it. Then we're going to go ahead and import it into one CNC, which is what I'm going to use to generate the program for this thing to run this part. This here's it's a little bit more complicated. It's just, honestly, this program feels like it's made from the 1990s, like a lot of these industrial programs do. But we're just going to have a quick step to face the top of this, and then we're going to go in. And you can see there's a space in between these parts as we go here. But then we're just going to go in and we're going to make the 3 diameters. Being careful to not go too deep. When I actually drew the part in SolidWorks, I wasn't thinking, and I just assumed I had a 2-inch bit here, so went ahead and corrected that since I don't have anything that deep, and we don't need anything that deep. So we're going to do those, then we're going to add chamfers because we're not animals, and after that we'll talk about how to make these. So let's start with the soft jaws. Oh wait, I'm posting this to YouTube. Click. Click. There we go, see, properly torqued. And then this here is just going to be to maintain our space, maybe. To maintain our space between our jaws when we're machining them. Obviously, when we're actually working on the parts, that will be removed. Now we need to make sure we've got an origin for our program. So if we look at the job sheet here real quick, we can see our origin is in the back left corner at the top. Now, just because I can here, on the Z, I'm going to go ahead and go into the part. I'm going to make a facing cut on top here. Just that way, the chamfers end up looking right, and it's also a reference surface when I'm trying to determine how deep in there the part needs to go. Next, we're going to go back and look at our job sheet, and we're going to make sure that the tools that we're going to use are actually properly loaded in the machine. So tool 2, this one right here, 3/4 inch end mill. Tool 4, this one here, we're going to have a 1/4 inch end mill. 5, the next one here, we're going to have a 3/8 inch end mill. And then 8, which is right over here, is going to have a 3/8 chamfer. Now, those, I didn't need to shuffle it around this time because that's what I was using for the other part of the manifold, so it just made it easier. So now we're going to go ahead and load our program over. This machine is over 20 years old, so it's only got 1 meg of memory. Honestly, that's kind of embarrassing even for a machine that's 20 years old. Computers had gigs of space back then. But either way, letting that slide. We're going to go ahead and load our software on here. Now this here is aluminum. I've got, well actually, all of the experience I have on this machine, other than these jaws back here that I made to hold the intake manifold, everything I've cut on here is all aluminum. So I'm pretty confident with the speeds and feeds on here. We're going to go ahead and set our rapids to slow to make sure that the movements are not going crazy where they shouldn't. Yeah, let's fire it up. So first thing I should be doing is picking up the 3/4 inch end mill and doing a facing operation. And as we know, this should be taking about 10 thousandths off the top. Passes the sanity check. Okay, well, it didn't take us very long to get to our first mistake. Let me show you guys. So you can see it only did 2 passes and it left a bunch of this material on here. And that's because normally for facing, I use a 2-inch end mill, so it tries to save the settings from one step to another, and it must have been set for the 2-inch face mill. So even though it did call out for the correct tool, that's what showed up. So either way, let me go fix the program real quick. Be right back. All right, let's try this again. Well, that worked a bit better now. Well, oh shush. Well, that worked a bit better now, didn't it? Of course, now we picked up that 1/4 inch end mill. We're gonna come do our little circles here, and yeah, let's keep it slow and go on in. Now we're just going to come take the last 10 thousandths off just to get that nice mirror finish, because we can. And now, let's chamfer it. All right, should be done. Oh yeah. I'm excited at how that looks. Let me get you in here. Man, I love the finish this machine leaves behind. And we can see, yeah, that's pretty much a mirror finish. Now I did notice we didn't, there's not a burr there, but this might still catch and leave a mark on the part. So let's remove that. All right, let's see how well it clamps our parts. Hold it well, and then these are cut a little bit oversized. Essentially, the first stop is going to come clean this up. This is about 3 millimeters thick. It's going to cut it down to 2 millimeters over. It's going to face it, and then we flip it, and then it's going to finish the part. So as long as it's above this, the whole place, we are good to go. And let's see if it leaves a mark on the outside. Focus. There we go. Yep, it does leave a mark on the outside. Let's see if we can clean that up first. Yeah, still leaving a little scratch on there. Yeah, so the parts would be completely functional, but I don't want to leave those marks on there if I can avoid it. So let's change the design of the jig just a little bit to flare these out on the ends. That way it doesn't come close to clamping on that. Plus, everything is still set up with the same 0, so it's easy to do it right now. All right, so what I did, you can see here, I ovaled it out just a little bit. It looks big on screen, but it's just a couple thousandths of an inch. What ended up happening is these guys are actually a little bit oversized, so it's just gripping on there. Everything's still zeroed and everything. This should only take the 3/4 inch finishing end mill. Let's let it go to town and see if that avoids this. All right, let's put this in where there are no marks. Oops. Helps if I actually remove the spacer. Okay. No marks over there. And no marks that way. Okay, clamped in. Oh, see, now they're just coming out. Oh yeah. You can see if it ever focuses. Come on. Here we go. There are no marks. Well, okay, that one had a tiny little mark to begin with, but if we look at this one, there we go. Yep, I am happy with that. Excellent. So we might as well use these marked up ones for the practice run for the next thing. Let's talk about what we're going to do first. Now, I'll preface this by saying I have literally never machined Delrin on CNC. I kind of have machined it on a manual mill and manual lathe, so I have some general ideas about how it cuts, and of course I do have access to the internet. I've looked up a couple numbers. but in some ways the numbers look really aggressive, and in others they don't. It's all about managing the heat in these things. So this one, I made a program that'll come in. It'll actually center drill these, not because we're drilling through these yet, but instead just so that the center cut, when we come in and face off with a 3/4 inch end mill, we're just going to plunge to face since it's more than big enough, and we're going to stay 2/10 of an inch proud of the surface. That way we can flip it and there's still some extra material there. At that point, the mill will come out. It'll present me the parts. While the program is still running, it'll pause. I should be able to flip the parts, go back in, and then it'll go in. It'll again center drill these, and then it'll drill them out and then spot face, not spot face, it'll face the ends, but again, just with that dip of the 3/4 inch end mill. And I just realized I gotta go change some things on here because I forgot the chamfers. And I'm gonna need to get the chamfers on the back side here before flipping the part. So let me go add that, be back in a second. All right. It's just plastic, right? What can possibly go wrong? Let's see if we can turn this into a puddle of goo. Wow. Okay. I thought happened so quick that I thought I might have not, completely machined it, but no, that's a beautiful surface. So let's keep going. Huh. We got the red light. Over travel. Okay. So the whole movement didn't. Let me shut this off. All right. Two things there. First, it didn't present the parts to me. And second, we chamfered a hole that didn't exist yet. Might not be a problem since it's in plastic, but, oh, actually, that chamfer is beautiful on the outside there, and actually beautiful on the inside too. So let me go see about fixing that home movement, because obviously that's not acceptable. But so far, speeds and feeds are looking great. All right. I'm not sure why I'm having so many issues moving in absolute machine coordinates, but for now, I'll pin that as a problem to move later, and I'm just moving it up 8 inches. This should work. Should work. Let's see. All right. Hey, and we're paused. Okay, so it should want this flipped now. Let's see how she goes from here. I think it worked. And we should have an 18 millimeter tall. Okay, 18.22. Gonna need to adjust that, but either way, yeah. And everything is nice and shiny except for those marks we put on earlier. So let's try another set and see if we can avoid marring them this time. Now, there we go. Here's our fuel rail spacers. Nice, made out of Delrin. No unnecessary scratches on it. All I need to do now is make 58 more of these. So I'm gonna get to that. I'll catch you guys in the next video.